Have you ever pondered whether we're really alone in the universe? Then again, is there more to our existence than what we see? Envision a situation in which the James Webb Telescope finally reveals that we live inside a black hole. Join us as we uncover more about this vital news that will make you question everything you thought you knew about the universe. So, what exactly are black holes? They're like something out of a bad dream. Sure, you might have seen them in sci-fi movies, but they're even more frightening in reality. As shown by analysts, black holes are thought to be enormous amounts of matter packed into an incredibly small area. Imagine a star several times more massive than the Sun, compressed into a space no larger than New York City. The gravitational pull is so intense that nothing, not even light, can escape from it. Scientists have been fascinated by black holes for quite some time. They've studied objects in space so massive and dense that they can trap light. The most well-known theories about black holes were predicted by Einstein's theory of general relativity. Essentially, when a gigantic star reaches the end of its life, it collapses, leaving behind a dense core. If this core's mass is several times greater than that of the Sun, gravity overwhelms everything, leading to the formation of a black hole. Black holes are difficult to detect since they emit no light. However, analysts have found ways to infer their presence by observing their effects on surrounding matter. For instance, if a black hole passes through a cloud of interstellar material, it pulls the matter toward it in a process called accretion. Moreover, when a star gets too close to a black hole, it can be destroyed, emitting X-rays in the process. Black holes also have enormous effects on their surroundings. They can consume nearby stars, emit powerful gas blasts, and even influence star formation, accelerating it in some regions while slowing it down in others. But where do black holes come from? Picture a star, once magnificent and bright, meeting its ultimate fate in a stunning explosion called a supernova. From the remains of these fallen giants, black holes emerge. Most black holes are born from massive stars that have reached the end of their life cycle in a supernova blast. Smaller stars, when they die, turn into something known as neutron stars, extremely dense but not dense enough to trap light. However, if a star has at least twice the mass of our Sun, it collapses under its own gravity, forming a black hole. Strange things happen near the surface of a black hole. Time itself begins to warp. From the perspective of a distant observer, time appears to slow down near the event horizon, the point of no return for anything that falls into a black hole. Perhaps the star's clock ticks at a different speed compared to ours. Occasionally, two smaller black holes collide and merge, forming a much larger and even more terrifying black hole. If a black hole interacts with a neutron star, they create an unimaginable cosmic nightmare. Scientists have been grappling with the size of these massive phenomena for quite some time. Black holes come in two general sizes, small and massive. However, small is a relative term. Stellar black holes, which are remnants of massive stars, can be anywhere from 10 to 20 times the mass of the Sun. There could be up to 1 billion of them in the Milky Way alone, a staggering number of black holes capable of devouring anything in their path. But wait, there's something even bigger. Supermassive black holes exist at the other end of the spectrum. They are millions, if not billions, of times greater than the Sun and reside at the center of massive galaxies, including our own Milky Way. These colossal voids pull everything toward them with immense gravitational force. The renowned physicist Stephen Hawking dedicated much of his life to studying black holes. His lectures provided invaluable insights, though some of his theories couldn't be confirmed due to technological limitations. However, hope is on the horizon. One groundbreaking scientific instrument is revolutionizing our understanding of the universe, the James Webb Space Telescope, JWST. The JWST is no ordinary telescope. It's an engineering marvel, a testament to human ambition. Sure, we've launched other space telescopes before, and they've done their jobs well. But this one? It's truly extraordinary. The JWST makes the Hubble telescope, which has served us for decades, look like a mere speck in comparison. The cost of this cosmic wonder? A staggering $10 billion. Yes, you heard that right, a number with enough zeros to make your head spin. It took the combined efforts of NASA, the Canadian Space Agency, and contributions from over 300 institutions to bring this marvel to life. But such an ambitious endeavor comes with its own set of challenges. The JWST is venturing into the unknown, pushing the boundaries of human knowledge, and taking us to places we've only dreamed of. Since its launch, NASA has announced that the JWST has enough fuel to last more than twice its expected mission life. The telescope has already traveled over 1 million miles to reach its orbit around the Sun, where it will remain indefinitely. Along the way, it successfully deployed its massive 5-layer sunshield and enormous primary mirror, both of which had to be folded to fit onto the launch vehicle. Now, after meticulous alignment and calibration, the telescope is nearly ready for full operation. One of the most fascinating milestones? The JWST recently captured its first images of starlight. The first photograph taken by the telescope was of a star called HD 8446, resulting in a mosaic of 18 scattered bright spots, each captured by one of the telescope's 18 mirror segments. Later, NASA released another incredible image, an intentionally hexagonal arrangement of these reflections, marking a major step toward producing clear, focused images. Once the observatory successfully aligns its individual mirror segments, it will begin the final image stacking process, combining the 18 separate images into one clear view. Thanks to its cutting-edge technology, the JWST will allow researchers to study the early stages of the universe, shedding light on what happened after the first stars formed, during a period known as the Epoch of Reionization. This period, known as the Epoch of Reionization, occurred hundreds of millions of years after the Big Bang. It was a time when the first stars and galaxies began to emerge, lighting up the once dark universe. The James Webb Space Telescope, JWST, is designed to peer into this distant past, capturing infrared light from celestial objects billions of light-years away. By doing so, scientists hope to answer fundamental questions. How did the first galaxies form? What role did black holes play in shaping them? Could these early structures hold clues about the formation of life itself? But the JWST's mission isn't just about looking into the past, it's also about searching for life beyond our planet. One of its primary objectives is to analyze the atmospheres of exoplanets, planets that orbit stars outside our solar system. With its powerful instruments, the telescope can detect chemical signatures in these distant worlds, identifying elements such as water vapor, carbon dioxide, and even methane, potential indicators of life. Imagine if the JWST were to discover an Earth-like planet with an atmosphere similar to ours. Such a discovery would fundamentally change our understanding of the cosmos and our place within it. Are we truly alone, or is life more common than we ever imagined? The telescope has already provided astonishing data, offering glimpses of planets orbiting distant stars. Some of these exoplanets exist in the habitable zone, the region around a star where conditions might be just right for liquid water to exist, a key ingredient for life as we know it. However, while the JWST is an incredible leap forward, it also comes with challenges. Observing the early universe requires extreme precision. The telescope must be kept at incredibly low temperatures, below -370 degrees Fahrenheit -223 degrees Celsius, to detect the faintest infrared signals. Its massive sunshield, which is as large as a tennis court, plays a crucial role in blocking heat from the sun, Earth, and even the telescope itself. As NASA fine-tunes its capabilities, the world eagerly awaits the groundbreaking discoveries the JWST will bring. Will it uncover new galaxies that defy our understanding of physics? Will it detect biosignatures hinting at extraterrestrial life? Or will it challenge everything we thought we knew about the cosmos? One thing is certain, we are on the brink of a new era in space exploration. The universe has always been full of mysteries, and with the James Webb Space Telescope, we are closer than ever to uncovering its deepest secrets. Of radiation, this time period is referred to as when neutral hydrogen was reionized, made to have an electric charge again, by radiation from these first stars. This includes looking back billions of years, which is only possible with a powerful telescope. Similar to the original, it will also assist scientists in finding exoplanets, which are incredibly difficult to detect due to the way they interact with the stars that host them. Powerful sensors will be able to observe these planets in more detail, including, in some cases, imaging their atmospheres. Understanding the environments and planetary conditions could help scientists better predict whether certain planets are habitable or not. In addition to studying the formation of galaxies, researchers aim to understand how matter is organized on a large scale. This, in turn, enables us to observe how the universe evolved. The spiral and elliptical galaxies we see today evolved from different shapes over billions of years. Examining the past is one of the initial objectives, studying the earliest galaxies to better understand their development. Scientists are also trying to figure out how we got the range of galaxies that are visible today and the current ways galaxies form and build up. But the most important question is, will the James Webb Space Telescope help us answer the most fundamental questions of all? Are we alone in the universe? Are we living inside a dark hole? The JWST has already been on the hunt, and guess what it found? Compounds called polycyclic aromatic hydrocarbons, PAHs, hiding around those massive, supermassive dark holes in 3 active galaxies. These carbon-based molecules with ring-like structures are like the goth kids of the universe. They're everywhere, from distant galaxies to comets in our solar system. Now, they're not just interesting because they could be the building blocks of life, but also because they help astronomers track star formation. When ultraviolet radiation hits these stars, they glow and emit infrared light, a signal that can be detected by the JWST's mid-infrared instrument, MIRI. This is often a sign that there are some young, hot stars hanging around. But wait for the twist. Astrophysicist Ismail Garcia Bernard from Oxford University decided to study 3 active galaxies. NGC 6552. NGC 70319, part of the famously renowned Stefan Quintet. NGC 7469. These galaxies are millions of light-years away in the depths of space. What Garcia Bernard found now is darkness, something that will make your hair stand on end. In those central regions where the dark holes dominate, he found a mass of stars. Sounds incredible, right? Well, here's where it gets chilling. The radiation near those supermassive dark holes distorted the stars, changing them into larger, electrically neutral versions of themselves. The smaller, electrically charged stars vanished into oblivion. Imagine being consumed by the darkness itself. But wait, there's a glimmer of hope, or maybe not. The ultimate question here isn't whether we're alive. Instead, it's if we really exist. Does everything around us exist because of the dark hole we're in? Everything connects with the theory that maybe we're not just living inside a dark hole, but rather inside the event horizon, the space between the universe we know and the unknown. Could it be that everything is connected inside a dark hole? The James Webb Space Telescope is out there right now, searching for answers to the unknown. Stay tuned. Perhaps, just maybe, it will force us all to reevaluate everything we thought we knew about existence. The truth might be far more twisted than we realize. As the JWST continues its mission, it will push the boundaries of our understanding and possibly answer questions we've been asking for centuries. It's not just a telescope, it's a window into the deep mysteries of the universe. Its findings might not only reveal the secrets of dark holes and exoplanets but also help us understand our place in the cosmos. Will it answer whether we are truly alone? Will it help us discover other life forms, perhaps hidden in the depths of space or in the atmospheres of distant planets? The JWST's powerful instruments have the ability to go far deeper into the universe than any telescope before it, revealing structures and phenomena that were previously invisible to us. It's a tool that could change everything we thought we knew, about the cosmos, about gravity, and even about time itself. The more we understand dark holes, the more we may come to realize how interconnected everything in the universe truly is. Perhaps we are all part of a larger cosmic story, one that the JWST will begin to unravel. But the answers it uncovers won't come without more questions. The more we learn, the more we might wonder about the true nature of reality. Are we simply passing through a cosmic experiment? Or are we, as we seem, part of a greater plan, one that stretches across dimensions we can't yet comprehend? The JWST will be at the forefront of this inquiry, looking at the universe in ways that challenge our imagination and understanding. What's more, this telescope will likely change the future of space exploration and the way we think about galaxies, stars, and black holes. As we move further into the unknown, the JWST promises to help unlock the deepest corners of space, perhaps allowing us to understand things like the Big Bang, dark energy, or the true mechanics behind gravity. It's a thrilling thought that, with the aid of this remarkable machine, humanity could uncover answers that have eluded us for millennia. As we sit back and watch its discoveries unfold, one thing is certain. The James Webb Space Telescope represents humanity's thirst for knowledge, our unyielding curiosity about the universe, and our drive to understand the unknown. It's more than just a project or an instrument, it's a reflection of who we are as a species. Looking to the stars, not just for answers, but for understanding. As the James Webb Space Telescope, JWST, continues its mission, it peels back layers of cosmic mystery, revealing secrets hidden for billions of years. Every new image, every spectral analysis, every faint whisper of light from distant galaxies challenges our perception of reality. But what if the biggest revelation isn't about what's out there, but about what's missing? The void between stars. Dark energy. Dark matter. The unseen forces shaping the universe. They outweigh the visible cosmos, yet remain elusive, like shadows cast by an unknown source of light. JWST's infrared sensors are designed to peer into these voids, to search for clues about their true nature. But as scientists analyze the data, they begin to notice patterns, or rather, the absence of them. Regions where galaxies should be, yet nothing appears. Signals that start and stop abruptly, as if something beyond our understanding is watching back. The deeper we look, the stranger the findings become. A cosmic echo. One discovery, in particular, has astrophysicists reeling, an anomaly in the cosmic microwave background radiation, the afterglow of the Big Bang. It was always assumed that this radiation was uniform, spreading evenly across the universe as space expanded. But the JWST has found distortions. Places where the radiation bends as if passing through something, or someone. Some speculate it's evidence of massive structures made of dark matter, invisible cities floating in the void. Others whisper a more chilling possibility. What if these distortions are echoes? Signs of something speaking back to us, from beyond time itself? The mirror of the cosmos. One of JWST's more controversial projects is the search for a reflection, a point in deep space where light bends in such a way that it should, in theory, show us ourselves from billions of years ago. If we truly are living in a simulation, in a loop, or inside an event horizon, there should be evidence, a cosmic mirror reflecting our own existence. And perhaps, just perhaps, the telescope is already seeing it. But what happens if the reflection isn't quite what we expect? If the past looks different from what physics predicts? If something else is staring back? If the universe isn't just expanding, but repeating? The final questions. As the JWST continues its mission, the biggest revelations may not be about distant exoplanets, dying stars, or hidden galaxies. They may force us to ask the hardest question of all. What if the universe isn't meant to be understood? What if every answer leads to a truth we were never supposed to find? The telescope searches. The data comes in. The numbers change. The unknown stretches out before us, infinite and silent. But somewhere, in the cold expanse of space, a pattern emerges. And perhaps, just perhaps, we were never alone after all.